Hello, pre-calculus and algebra 2 students. This is Mr. Kraft coming to you from my room as usual. I want to discuss today's handout, which is about determining domains of functions, which I think for both of the classes I've talked about before, but let's go ahead and review that so you know what's going on. So, in the simplest way of putting it, a function is a relationship between two sets of numbers. The x numbers I could call inputs, or I could call them independent variables, or most mathematically, I call them the domain. The domain is the list of all the x's. So the y then logically stands for the outputs or the dependent variables, or the range. So to give a very simple example, if this, well, first off, when we use function notation, instead of using y, we use f of x to emphasize that whatever the dependent variable or the range or whatever is depends on or is a function of the independent variable, the x. So, if I did a partial t-table for some possible values of this, if I put in 0, function of 0, 3 times 0 is 0, 0 plus 4 is 4. 1 times 3 is 3, 3 plus 4 is 7. 2 times 3 is 6, 6 plus 4 is 10, and so on. You could go on and on and on and on as much as you wanted. So, the issue, more broadly, with any function, when we talk about finding its domain, the range is important too. Sometimes we need to know the range, but the domain is kind of more important because everything in the range depends on the domain. So if you know what the domain is, you can always go from there and figure out the range. So really what you're saying with domain, what you're really saying is what values of x are you allowed to use? And in general, there's no limitation on that. After all, I could put in, if I use that t-table again, before I used 0, 1, and 2, I could use negative 50 if I felt like it. 3 times negative 50 is negative 150. Negative 150 plus 4 is negative 156. I could use 2/3. 2/3 times 3, the 3's cancel out. 2 plus 4 is 6. I could use a million. 3 times a million is 3 million, plus 4 is 3,000,004, and so on. There's no x number that I could not use for this function, and so that's why d for domain of this function would be, well, let me write it differently than that. I could either say negative infinity to positive infinity, or this is easier, this is what I would do, the double backed r, which is just the way of saying all real numbers. And this here is the default domain. Most functions that you have, their domain is all real numbers. So if you had something like this, f of x equals 578 x to the 30th minus 249 x to the 18th. Well, I don't have any desire to actually plug anything in that besides 0. If I put in 0, I get f of x equals 0. If I plugged in with a small number in, 3 to the 30th would be fantastically big. But you know what? It doesn't matter. There's no number I can put in there for x that will cause a problem, so domain is all real numbers. Boom. Easy. The only cases you have to worry about are fractions and even indexed roots. And for what you have on your assignment, for what we normally do, basically square roots. We're not going to do fourths or sixths or exotic weird stuff like that. So we'll come back to the roots. Let's start with fractions. And with fractions, there has to be a specification there. So I'm going to say with x in, well, I guess I should be more general. With variable in denominator. If you will think back, people, this should kind of ring a bell. I know that you guys that I had last year, I know you did that. And I'm pretty sure that I did that with Pre-Cal and Algebra 2 both this year already. But if I didn't, pay attention, you'll learn, it's fine. So, if I had fx equals 37x minus 18, there's no fractions at all, so boom, domain equals all real numbers. If I had f of x equals x plus 2 over 3, well, you do have a fraction, but the denominator is a number, not a variable. So, once more, no worries, all real numbers. The only time that this becomes an issue is when you have something like this. F of x equals 3 over x. I cannot plug anything I want to into that. I can plug in 1 or 2 or 5 or 17 or negative 84, but I cannot put in 0. Why? Because that gives me 3 over 0, and you can't divide by 0. Under the line is undefined. And we do not want to have anything undefined. So the way you write the domain for that is your set builder notation, your curly brace, x in the long line. What this means is x such that, or so that, and you write x is not equal to 0. And this here is your answer. Domain is x so that x is not 0, not equal to 0. Anything else is okay, because there's an infinite number of numbers. Rather than saying what's all in the domain, it's easier to say what's not in the domain. Okay, suppose you had something a little bit more involved. Fx equals x plus 12 over 3x minus 8. Okay, what's on the top is irrelevant. You're never going to worry about the numerator on these guys. You always worry about the denominator. And you set the denominator equal to 0 because you want to see what makes it be 0. And then when you know what makes it be 0, you throw that out of the domain. So now this gets back, I know you've heard me say this 50 times, SAM, simplify, add, multiply, which I'm not going to write out. I'm going to add 8 to each side. 3x equals 8. And then divide out by 3. So 8/3 would make this be 0 and thus undefined. So I throw out 8/3 x so that x is not 8/3. That is my answer for that. For fractions, it's always going to be x so that x is not something. Could be more than one thing. Suppose you have f of x equals 7 over x squared plus 5x plus 6, which hopefully you recognize when you set that denominator equal to 0 is just a simple quadratic. Reverse FOIL. So we factor it, and I'm not even going to comment on that at this point. I hope you're comfortable with this by now. I set each part equal to 0. X equals -2 and x equals -3. So we throw those guys out. We call the mathematical bouncers x so that x is not -2, -3. And that's it. This is how problems involving fractions work. Okay. The other situation is square roots, which are a slightly different kettle of fish. So I'm going to say variable in radicand. So suppose I had f of x equals x plus the square root of 5. The radicand, if you recall, stuff inside the square root sign. But radicand sounds cooler, it sounds more official. 5 is not a variable, so your default kicks into play. Domain is everything, all real numbers. I mean, 5 is just a number. The square root of 5 is just a number. 2.236 approximately. So the only place where this becomes an issue is when you start having variables under the radical. Now in this case, you're going to have not equal to like we did with the fractions. You're going to have a greater than or equal to. Any positive number here, 4, 5, 6, 7, 8, would be fine. 4 plus 3 is 7. The square root of 7 can be done. 5 plus 3 is 8. The square root of 8 is 2 square roots of 2, etc. -3 would be fine because the square root of 0 is 0. 0 times 0 is 0. So that's no problem. The issue is when you get to negative numbers. The square root of -1 is I, as you recall. But the problem is domains are on the real number axis, which is down here. Imaginaries are up there. So as soon as you go imaginary, those exist. They are valid, but they can't be part of the domain. So what I do is I take my full radicand and set it greater than or equal to 0. Then I do my SAM once more, and I get x is greater than or equal to -3. So now domain equals x so that x is greater than or equal to -3. That's my answer there. So let's do another one like that. Let's do something more interesting. So f of x equals, I don't know, the square root of 7x plus 5. So I take my radicand, 7x plus 5, and I set it greater than or equal to 0. So my SAM, simplify add, so I'm adding a negative 5 to each side. And recall, well, never mind, I'll show you an example of that in a minute. So x is greater than or equal to negative 5/7. So domain is x so that x is greater than or equal to negative 5/7. Easy as that. One more example. Suppose I had f of x is the square root of 8 minus 2x. Now this gets interesting. I set my radicand equal greater than or equal to 0, and I take my 8 over, as I usually would. That gives me negative 2x is greater than or equal to negative 2/8. I divide both sides by a negative 2. It's been a while since we talked about this, people, but remember, when you divide or multiply an inequality by a negative, you switch the sign of the inequality. It goes from being greater than or equal to less than or equal. Negative 8 divided by negative 2 is positive 4. So now domain is x so that x is less than or equal to 4. That's the answer for that. Okay, now all I want you to do on these problems is to give me the domain in this format, typical set builder notation. If I have given you something where the answer is all real numbers, you get off easy. You can just show me the double-backed r. If it's anything else with a fraction in the denominator or a radicand with a square root, then I need you to give it to me in set notation with the curly braces and the x so that. Okay, I hope that is all clear, and I will talk to you later. Till then, I'll see you. Bye.